Okay, I want to go right into inequalities. Just a reminder, when you have an inequality, if you have some number A is greater than some number B, then I can add another number C to both sides and preserve the inequality. A plus C will still be greater than B plus C. All right? Same thing for subtracting. If I still have A is greater than B, I could subtract C from both sides and I would still have a valid inequality. Now remember, when you multiply A greater than B by some number C, it preserves the inequality so long as C is positive. If C is not positive, if it is negative, then the inequality sign will flip. Okay. This is a compound inequality. X is greater than 3 but less than 11. Or we could read it as 3 is less than X is less than 11. And 4 is less than Y is less than 9. So what we did is we combined both, and we did the 3 plus the 4, the X plus the Y, and the 11 plus the 9. And because we added left parts, middle parts, and right parts of both equations, we can actually say this will hold true. That 3 plus 4 is 7, X plus Y is X plus Y, and 11 plus 9 is 20. And so you have a combined inequality. All right, if they say that 2x must be less than 9, which must be less than 5x, which value cannot be equal to x? Well, let's place a 2 in that formula. Is 2 times 2 less than 9 less than 5 times 2? Well, I get 4 less than 9 less than 10. That works. Is 2 times 3 less than 9 less than 5 times 3? I get 6 is still less than 9, which is less than 15. That works. Is 2 times 4 less than 9 less than 5 times 4? Here I get 8, still less than 9, which is less than 20. That works. Is 2 times 5 less than 9 less than 5 times 5? Well, 10 is not less than 9, but that is less than 25. However, because this part of it does not work, this is the only one that cannot be equal to x. And an absolute value problem. All right, this goes with the inequalities because whenever you solve an absolute value problem, after you have isolated the absolute value, which means there's nothing on the left side of the equation but what's between absolute value bars, you have to set up two equations. One will look like this. It basically looks like this equation, only you're subtracting the bars out of it. But the other equation looks slightly different. You do an x minus 5, change the direction of the inequality, and then change the sign on the right of the equation. So now when I solve this, I'm going to add 5, and I'm going to get x is greater than 19. And when I solve this, I add 5, but I get x is less than negative 9. Okay? So, it's either going to be greater than the number 19 or less than a negative 9. Both of these will be solutions to this original equation. Okay. When you're doing a problem like this, 5 times 10 to some power n plus 2 times 10 to the 7th power equals 2.05 times 10 to the 7th. Well, if we subtract, we don't know what to do with the n's yet, so let's just subtract 2 times 10 to the 7th from 2.05 times 10 to the 7th. Okay, this cancels and you get 5 times 10 to the n is going to be 0.05 times 10 to the 7th. And because I want to make this a 5, I'm going to move this 2 decimal places and make that 5. And since I moved it backwards, I have to raise that to 2 less than this power. So I'm going to get 5 times 10 to the n is 5 times 10 to the 5th. And so the n power must have to be this number. All right, that's all I have to say today. You have 3 quizzes to do: rational linear equations, proportions, and inequalities. Remember to read your examples before you start your test, your quizzes. Then I want you to remember to do your classwork and homework problems in your binder set for day 8. Those will be due next class. Thank you, and I hope you do well on your quizzes.